Now we're looking at section 1.4, Introduction to Limits. So the concept of a limit, let's look at these three functions here. They look identical except for what's happening at the function value of x equals a. In the first graph, everything is defined. You've got f of a equaling the y value of L. In graph B, though, we still have f of a, but notice how there is a hole on the continuous part of the graph there at L, and f of a is actually defined somewhere else. So f of a exists, but does not equal L. In the third graph, f of a does not even exist. There is a hole there where x equals a. But one thing I want you to notice is that regardless of what is happening at x equals a, the rest of the function is approaching L as x is getting closer and closer to a from both the left and the right. In the first graph, from the left and the right of a, it's still approaching the y value of L. The second graph, it is still approaching L from both sides. And again, in the third graph, it is still approaching L. This is the concept of a limit. So let's take a look at the notation. Suppose f is defined on some open interval that contains a, except maybe a itself. We can state the limit of the function as x approaches a by this notation here. F of x is the function, x is approaching a, and our L is the function value or output value the graph is approaching. In other words, it's approaching AL even though it may not be defined at AL. Now this notation reads, the limit as x approaches a of f of x is L. You may want to put a in quotes. And notice that that arrow is what is representing the word approaches. Notice they did not say equal. So let's look at example A. We're considering the function g of x equals x minus 1 divided by the quantity x squared minus 1. It is graphed to the left here in blue. And notice there is a hole on the graph where x equals 1, but it is defined at a point higher where y is 2. If we were to look just at the function g of x, we would see that as x is approaching 1 from both the left and the right-hand side, the function is approaching 0.5. Therefore, we would say the limit as x approaches 1 of x minus 1 over x squared minus 1 equals 0.5. The equation given for g is not defined at 1, we have a hole. But remember, if we consider this entire graph as function f, we do have the point at 1, 2. This tells us f of 1 is 2. This is to illustrate that it is possible that a limit as x approaches a number could be different than the actual function value at that number. Then question C asks, what about the vertical asymptote x equals -1? What is the limit as x approaches -1 from the right? As we are approaching x from the right, where is the function headed? It is going towards positive infinity. So even though this is not an actual value, it does give a sense of direction.